Airflow measurement, F1. Objectives. Calibrating and assessing a number of different obstruction devices used for measuring the volume flow rate of air in a pipe at low Mach numbers. Comparing the results of this experiment with those from the published literature. Preliminary measurements. Several preliminary measurements should be done to gather the required data to calculate the air density. These measurements are the room temperature, the parametric pressure, and air relative humidity. These data can be taken from the digital weather station installed in the lab. As a part of the preliminary measurements, relative air humidity can be measured by using the hygrometer or the sling psychrometer and the psychrometric chart. The sling psychrometer consists of two thermometers mounted together with a handle. The other has a cloth wick over its bulb attached to a water container and is called a wet bulb thermometer. When a reading is to be taken, the water container should be filled with distilled water. The sling psychrometer is whirled around for about 1 to 1.5 minutes. After that, the temperatures of both thermometers are read. During the whirling, the water evaporates from the wick, cooling the wet bulb thermometer. The relative humidity can be determined using the measured dry and wet bulb temperatures and the psychrometric chart. Experiment procedure. Open the LabVIEW software by clicking on the software icon. Enter the required information, such as the room temperature in degrees Celsius, the atmospheric pressure in millimeters mercury, and the relative humidity. Press OK. Press the Start Test icon. The LabVIEW will indicate a 0 airflow speed on the speed scale. Turn on the compressor. Attain the maximum flow rate by fully opening the gate valve. The LabVIEW speed scale will show the change in the airflow speed. Wait 2 minutes to achieve the steady state condition and then press OK. At this stage of the test, the LabVIEW software will control the process of measuring pressure of each pressure tab to create the pressure profiles across the 4 obstruction devices. This process is performed using the SCANavalve, the mechanical rotor, and the pressure transducer. Determining the exit flow profile. To determine the flow profile at the exit of the tube, the pitot tube readings at several radii positions should be collected and processed by the LabVIEW software and the pressure transducer. These positions approximately represent the mean velocity for 5 concentric equal areas. During this step of the experiment, follow all the instructions as they appear on the LabVIEW window. Set the micrometer connected to the pitot tube to the R1 position and then press Next on the LabVIEW window. Push the Reset and Data button on the data logger to enter the pressure reading to the LabVIEW window. Press Next and set the micrometer to the next radius and follow the same steps. After finishing determining the pressure at R7, center of the tube, press Next and the LabVIEW will store all the data of the pressure tab readings in inches water across the different obstructions and the pressure readings at the exit. To set the second run, close the gate valve gradually to obtain a reasonable minimum air flow velocity, 5 to 6 meters per second. To perform Run 2, follow the same procedure of Run 1 to obtain the pressure profiles across the 4 obstruction devices and the pressure readings at the exit. Calculate 3 other runs by choosing equally spaced airflow rates in between the maximum airflow in Run 1 and the minimum airflow in Run 2. After finishing Run 5, LabVIEW will finish saving and tabulating the pressure tabs readings across each obstruction device for each run. Also, LabVIEW will provide graphs of the pressure profiles across each obstruction for the 5 runs. A hard copy of all these pressure readings tables and pressure profiles graphs can be obtained by using the print option in LabVIEW software.